Hello everyone and welcome to class of IPV4 Subnetting. In this class we are going to discuss about subnetting. An IP network like Class A, Class C network executes IP addresses that follows the same preset rules. These Class A, Class B, Class C rules they define for a given network that all the addresses in the network have same value in some of the octets of the addresses. Class B network like 172.16.0.0, it consists of all addresses that begin with 172.16 like 172.160.0, then 172.160.1, so on up to. So IP subnet is simply a subnet of Class A, Class B or Class C. So for analyzing subnets and addressing needs, we have multiple questions that which host which host should be grouped together into a subnet, how many subnet does this interwork require, how many host IP address does each subnet require, will you use a single subnet site for simplicity or not. So there are some predefined rules and these are the rules for which hosts are in which subnet. Every device that connects to an IP interwork network has an IP address. So these devices include computers used by end users, servers, mobile phones, laptops, networking devices, etc. So any device that uses IP to send and receive packets needs an IP address. So to make the routing work efficiently, IP addressing rules group addresses into groups which are known as subnets. Addresses in different subnets are separated by at least one router. So every device that connects to an IP interwork needs to have an IP address. Any device that uses IP to send and receive packets needs to have an IP address. Next is to determine the number of subnets. To determine the number of subnets required, the engineer must think about the interwork and count the location that needs the subnet. To do so, engineer require access to network diagrams, VLAN configuration, details about the LAN links. So it has to plan one subnet for every VLAN, P2P serial link which is point-to-point serial link, and Ethernet WAN which is Ethernet line service. This is the diagram. Now the number of subnet required can't be fully predicted with this figure. 3 subnets will be needed for the WAN links, 1 per link. However, each LAN switch can be configured with a single VLAN or multiple VLANs. You can be certain that you need at least one subnet for the LAN at each site, but you need more also. So in this case, this figure shows the VLAN counts in addition to the same layer 3 topology. It also shows that the central site has many switches, but the key fact on the left, regardless of how many switches exist, is that the central site has a total number of 12 VLAN links. So similarly, this figure lists each branch as having 2 VLANs. Along with the same 3 WAN subnets, this interwork requires 21 subnets also. Now determining the number of subnets, we require at least one subnet for LAN, but we need most also. Determining the number of hosts per subnet. Every device that connects to a subnet needs an IP address. So for a totally new network, we have to look at the business plans. That means number of people at site. Now devices on order or so on. So when expanding an existing network to add new sites, we can use existing sites as a point of comparison, and then we can find out that which site will get bigger or smaller. We require to count router interfaces IP address in each subnet and switch IP address used to remotely manage that switch. So instead of gathering data for every site, planners often just few typical sites for planning purposes. Instead, we have to analyze to the fact that point-to-point links need a subnet with just 2 IP address plus any analysis of one or more subnets. This is about IPv4 subnetting. Thank you.